Hello and welcome to the Thursday, April 3rd, 2025 edition of the SANS Internet Storm Center's Stormcast. My name is Johannes Ulrich and today I'm recording from Jacksonville, Florida. Our SSH honeypots did pick up some odd username password combinations yesterday. Now, there are a lot of odd username password combinations, but these sort of crossed our thresholds, what we consider significant. And looking at it further, it actually may be somewhat interesting. The username that we are seeing, and this was really just last week, was T128 and the password 128T routes. Turns out this is a Juniper product, actually originally created by 128 Technologies. So that's where the T128 and 128T routes part comes from. And this is now a Juniper product, a part of their Session Smart networking platform. This is one of the default passwords being used. There's also root and then the same 128T routes password that is being used here. It's not really clear why we saw sort of this surge last week. There is always a little bit scanning for this password combination, but sort of in the single digits, nothing really that I consider significant. Last week, we had it sort of in the 20,000 attempts per day. So certainly way more, multiple orders of magnitudes more than what we usually see for this combination. Now, doing some Googling around this, I saw some support forum posts where users apparently are having issues disabling this password. So this is a well-known password that you're supposed to disable per the manual, but apparently this sometimes doesn't work quite right. So double check and maybe add this combination to your own internal SSH scans. Make sure that you have nothing exposed that works with this username and password combination. And then thanks to Evan Connelly for writing up an interesting vulnerability that Evan found in Verizon's API. Now, typically don't really sort of talk a lot about vulnerabilities like this, but in this case, I think there's some lessons to be learned from the vulnerability and beyond. So that's why I'm covering it here. The vulnerability is actually interesting because it's sort of a classic mistake that people are making when they're doing authentication and access control. The vulnerability in question here affected an API that Verizon offers as part of its call filtering service, where a user may request a list of their call history, basically sort of a log of their calls. In order to do so, you connect to the API endpoint, you authenticate with a JWT, which is not a bad idea. That JWT then includes your phone number. So you would think, okay, we're done. Pretty straightforward. Verizon just takes the phone number from the JWT and returns your call log for that phone number. Well, that's not exactly what's happening. What we have in addition to the JWT is a header that indicates what phone number you would like to retrieve. And that header, of course, is not authenticated. So Verizon reads the phone number from that header instead of the JWT. And that, of course, allows an attacker then to essentially authenticate for whatever phone number they actually own and then use the JWT with the header that actually indicates the phone number they would like to receive logs for to retrieve anybody's call history. Again, this only affected Verizon, but it's sort of a very classic kind of vulnerability where you're relying on non-digitally signed data like the header instead of using the digitally signed data like the JWT in this example. Verizon reacted appropriately here. Evan did report it to them and immediately acknowledged the report. And a month later, when Evan checked in again, well, the vulnerability was fixed. So good work here. No bug bounty involved here as far as I know. Now, the other problem to this is, of course, that, well, what this means is anybody's call history could have leaked. And this is a general problem that has happened before, where providers like Verizon have offered web interfaces to retrieve like SMS messages, to retrieve call histories. And then in these web applications, or here the API, they had vulnerabilities allowing for the data to leak. That's something that you need to be aware of, and yet another reason why you have to be a little bit careful with trusting phone numbers, trusting SMS messages to stay private. And yesterday I hinted that there was a Gmail encrypted email story that I wasn't really sure about covering, but well, looks like it's right. And I think I know now a little bit more why it makes sense and also of the issues. So the problem that Gmail is trying to tackle here is end-to-end encrypted email. The big problem with email messages is that while they usually are encrypted with TLS as they traverse the internet, the end user doesn't really have any control over that. So that's where end-to-end encrypted email comes in, where I'm encrypting my email in my email client before it's actually being sent to any mail server, and then the recipient will decrypt it. There are a couple solutions for this. There's PGP, there is SMIME already being supported by Gmail, but none of these technologies really has taken off, and in part it is just a usability nightmare, kind of to try to explain to a non-technical user how to get keys, how to get everything properly signed, and then also how to verify that the signatures are correct and such. So there are a couple of solutions now that are basically doing everything transparent to the user in the client. Proton Mail is probably the biggest one. They have a webmail client that then uses JavaScript to decrypt emails on the client, and the encryption keys themselves are only stored encrypted on Proton Mail's servers. So that way it's possible for them to encrypt the email using public keys, but you will then in your browser decrypt the private key and decrypt the email. All of this works pretty well. The problem is now, what if you send an email to someone not within Proton Mail? Well, that's what Gmail here is trying to address. I don't quite like the solution. That's sort of where my problem was yesterday. It's a very common solution to this problem, where if you're sending an email from Gmail using this new sort of encrypted email feature, the recipient will just receive a link. The link will tell them, hey, there is email waiting for you. Click on the link, and then you'll be asked to log into Google, and you'll present it with lower feature Gmail client that allows you to read the email, and I believe also do simple things like respond to the email. So the big problem I have with these kind of schemes is the link, and that of course is sort of a phishing attack waiting to happen. Again, usability, user interface is a big part of this. Now they put some administrative controls around this, and this is at first, at least, being only rolled out to Google Workspace users. So basically companies that are using Gmail, and they're giving their IT administrators here some control over making these messages the default, or also applying classification levels and such. Also some logging and data loss prevention. So your IT management is still able to access those encrypted emails. But sort of another sort of legal problem in some ways for end-to-end encrypted emails. Looks interesting. I'm still not quite happy with the overall solution because it involves the links. Haven't really seen anything better on the other hand. So let's see if Google makes something work here where others certainly have failed. Well, and this is it for today. So thanks for listening, and talk to you again tomorrow.